Hello my friends. Today I want to go over some Network Plus practice questions with you all. Thank you for joining me for another video, and if you're not a subscriber, please consider subscribing if you find this video helpful. I am on learn.comptia.org and I have a plethora of options here for practice questions. If you would, please follow along with me and put your score in the comments down below. If you want to see me do a different lesson with a different practice question topic, please leave that in the comments as well. This one goes out to Electro Belton, because he said he wanted to see me do more practice questions that I mentioned in the previous video. So you can thank Electro Belton for this video. Without further ado, let's jump right into it. Lesson 5, explaining IPv4 addressing. This should be a pretty familiar category, as IPv4 is a common topic when discussing networking. Question number 1. A help desk operator is troubleshooting communication issues for devices in different broadcast domains. What do the devices need to pass through to talk to each other? So, we know these devices are in different broadcast domains. That is key. We know that's a key because certain devices will separate broadcast domains while others will not. The switch will not separate the broadcast domain. So the way I think about this is if one device broadcasts on the broadcast address for that network, who will hear that broadcast and who will not? If a device was connected on the same switch, it would hear. A hub would also hear. A router connects different broadcast domains to each other. So, I'm going with answer C. A network administrator is working for a large company on a subnet that requires an 8-bit mask. Which of the following would that be? Okay friends, an 8-bit mask. So, an 8-bit mask is going to mean that we have 8 bits in the subnet mask. Alright, so simply what that means is we have 8 ones and there would be 24 zeros. We know that the IPv4 address is 32 bits in total. So if we have 8-bit mask, we have a 24-bit host address. Easy way to think of this is just to write out the ones. 1, 2, 3, 4. 1, 2, 3, 4. And we know that that would be 1 octet. 1, 2, 3, 4. Oh, that's actually already 8. So, yeah, the rest of the IP address would be, 8 and then 8, however many, and then 8. Okay, this was what an IP address looks like in binary. So, an 8-bit mask means we have 8 ones, which is equal to 255. If you do the math with binary, then you know that the first one is equal to 128. The second one would be equal to 64. The third one would be equal to 32, and 16, and 8, 4, 2, 1. So you can see we have 8 numbers here. These are the 8 ones represented in binary. If you add up all these numbers together, you get 255, which means our IP address will look like 255, 0, 0, 0. Or sorry, not our IP address, our mask, okay? So this is our answer, and it is right here as letter D. All right, we got it right. Letter D is the answer. It turns out we do get to review the answers. So 255.0.0.0 is an 8-bit mask. A short net mask allows for millions of hosts per network, but only 126 possible network addresses. Next question. A network administrator needs to break up a subnet into subnet masks containing 64 addresses. Which of the following subnet masks should the administrator use? Okay, so this is tricky. We need 64 addresses. The way I'm thinking about this, and I hope it makes sense for you guys, is that the bits remaining for the host address has to add up to at least 64 possibilities, okay? So, allow me to explain. If we have one host bit, we only have one host address. If we have 2 host bits, we get 3 host addresses. Well, not necessarily, because the first and last address must be used for the broadcast and the network and the broadcast address. So 2 bits gives us 1 usable host address. Okay? 4, and let's just keep going for the sake of time. I'm gonna skip ahead. So this would be 1, 2, 3, 7, 15. This gives us 31, but it's always going to be -2 because of that's first and last. So 31 is really 29. Okay. Now if we add 32 to that, we get 51. Still not enough. So we have to add 64 as well. All right. So we have 1, 2, 3, 4, 5, 6, 7 addresses, 7 bits here. Okay. So if we're coming from the left and going to the right, anyway, the next number would be 128. So we can assume that 128 is part of the mask, whereas these 7 bits need to be part of the host address because we need 64 addresses per subnet. So I believe the correct answer is D, because this answer gives us 1 bit in this octet that belongs to the mask and 7 bits in this octet that belong to the hosts. And that is wrong. So I added 1 extra bit that was not supposed to be there, okay? So 32 plus 16 is 48, plus 8 is 56, plus 4 is 60, plus these is 63. Well, okay. I don't perfectly understand this one, but that's okay. That gives you guys an opportunity to teach me. So if you would like, please explain the question or the answer down below. The explanations are all here, but in the interest of time, I'm gonna move on. So that just goes to show you, I don't know everything, and I was still able to pass the Network Plus. So if you got that question wrong too, don't be discouraged. You may still be able to pass the Network Plus as well. I thought I had a pretty good grasp on subnetting and network masks, but I definitely have room to improve. So thank you for bearing with me on that one. A client is trying to connect to a network. The client can get an IP address, but does not have internet access, and decides to see if they are issued an APIPA address. Which of the following would fall under the APIPA range? Okay, so APIPA is, I believe, stands for something along the lines of automatically programmed IP address, automatic private IP address. And so basically, if the computer cannot contact a DHCP server and it has not been assigned a static IP address, then it will automatically assign itself a private IP address. And this range is 169 to 254 through 169, 254, 255, 255. This is something I memorized with a flashcard. So just something you should know. And also the concept behind it about the whole DHCP server not being reached. That is very important when it comes to a troubleshooting question or a performance-based question. So let's check that answer, and that answer is correct. Here are the explanations. A security analyst is reviewing malicious packets and trying to understand the IPv4 header. What is the first field in an IPv4 header? This is a tricky one. I am not sure about what the answer is here. I think it's either protocol. I really don't know. It could be any of these 3. I'm pretty sure it's not source address. But honestly, I'm just gonna take a guess. So take a guess along with me. Leave a comment below if you get this answer right. Leave a comment below if you get the answer wrong. It was version. Okay. I thought it's protocol or version, but I really had no idea on that one. So definitely good to review. This is why these questions are great. They help you to know where you're still lacking some knowledge. So I would also say these questions are harder than the questions that were on the Network Plus. But that's good because it pushes you to learn even more. And then when you take the Network Plus, you're gonna pass without an issue, okay? So definitely I could go back and I could read, exam objective 1.5, lesson 5, topic 5A, etc. A help desk technician is reviewing the network layout in various areas. What is the purpose of subnetting? The purpose of subnetting is layer 3 segments. Okay, Subnetting creates layer 3 broadcast domain segments with fewer hosts. The trick with subnet design is to fit the scheme to the requirements for a number of subnetworks and hosts per subnet. I feel like I have the conceptual knowledge down really well, but some of the details and the finer details elude me, the specifics per se. A systems administrator attempts to allow one host on the internet to send content to other hosts that have identified themselves as interested in receiving the originating host's content. What should the administrator use to accomplish this? The answer to this one is multicam. Did you get it right? All right. A security administrator is investigating a CAM table flooded by an attacker. In the packet capture, what protocol should the security administrator filter on to look at related traffic? For some reason, I'm blanking out on what CAM table stands for. However, if it's something that's getting flooded, I'm guessing that it's an ARP table. Oh, I know. CAM table is related to MAC addresses. So yes, it would be an ARP table. All right, the TCP IP suite includes the address resolution protocol, blah, blah, blah. It doesn't tell us what a CAM table is, but I'm pretty sure it's just a, similar to a MAC address table. A security architect is dividing a network into logically distinct zones for security and administrative control. Which of the following should the security architect use? I'm going to go with VLANs, Virtual Local Area Networks. And that is correct. Here are the explanations. If you'd like to read them, pause the video. A security analyst is looking at traffic directed to 0.0.0.0 WAC 8. For what purpose is this IP range typically used? This would typically be a broadcast address. So answer C makes the most sense. A source address by client. No. Oh, a source address by client seeking a DHCP lease. Yeah, that makes sense. I'm gonna say it's that one. It could be A. I don't understand D as an answer. It's weird. All right, C is correct. Look at that. And moving on. A security researcher is looking at traffic directed to 192.0.2.128. What is this used for if used correctly? That is a good question, and I'm not sure I'm familiar with that address. And again, I don't understand why there's a letter D that says examples, but I'm gonna go with answer B, local network address not known. Let's see if that's correct. And that is not correct. The answer is D, examples. The subnet, something, something, are all set aside for use in documentation and examples. Oh, I did not know that. That's very helpful to know. Interesting tidbit. These IPv4 address ranges reserved for special use and are not publicly routable. Okay. I did know that they were not publicly routable. I did not know they were meant specifically for documentation and examples. So, there we go. Just learned something new by doing practice questions. And it's probably something that I'll remember more easily because I was stumped by this question. And from my understanding, 192 is simply a private IP address range. So, cool. A systems administrator is looking into communications issues on a server. If the destination IPv4 address is on a different IP network or subnet, where will the host send the traffic? All right, this is a conceptual question. Default gateway would be the answer. Next question. A network administrator wants to be able to address multiple address hosts. Which of the following would accomplish this task? Multiple address hosts. Broadcast would work. This is broadcast for a Mac. So I feel like that would also work. Unicast would definitely not work. And I'm not sure about this one, if that's something special or not. But I'm gonna say broadcast address. And it would have been broadcast and okay. Oh, I didn't select all that apply. I should have gotten that one right. I said it. I said this was also a broadcast. This is a broadcast for a MAC address. F is the last character in hexadecimal. So this is the equivalent of 255, 255, 255, 255 in IPv4 decimal. A security technician is looking at binary and trying to convert it to an IP address. The first field is 0011, 0011. What does this translate to in decimal? Alright guys, you know the drill. Figure out your own answer, see if you get it right, see if I get it right. And if I totally messed it up like last time, leave a comment down below and explain it for all of us. As a matter of fact, I would like to give a quick shout out to Damlaya Almanca. I don't know if I said that right, but he explained a binary and hexadecimal question in a previous video. So if you want to watch that, you can click on this here. But for this question, let's get to the bottom of it. 0011, 0011. What does this translate to in decimal? Alright, guys, I'm going to go ahead and say this one is not that hard. So, 0011, 0011. Alright, the first 0 represents 128. The second is 64. Let me put some more spaces here. The third digit would represent 32. And then we have 16 and 8, 4, 2, 1. Okay, so anywhere there's a 0, we do not count that value. Anywhere there's a 1, we do. So all we're really doing is adding up 32 plus 16, which is 48, plus 2, which is 50, plus 1, which is 51. Make sense? Alright, that is correct. So basically, every place of this binary digit or number is a power of 2. So 2 to the power of 1 is 1. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and so on and so forth. A network architect is planning a new setup for a new company that has yet to build buildings. Which of the following would the architect set up for a WAC16 network? Okay, this one goes back to Classful addressing, which is an outdated system but is still used to reference certain types of networks. We use classless addressing or CIDR addressing now. However, this is still good to know. So class A is basically all ones in the first octet. So that would be a WAC8. Class B is all ones in the first and second octet. Pretty easy to remember, WAC16. Class C would be the first 3, so that'd be WAC24. That's a very common network to use, is Class C. And Class D and E are different. I can't recall right now, but I know the answer to this question is Class B. And there we go, that is the correct answer. So, alright, so we got 73%. Not too bad. How did you do? Leave a comment down below. Let me know if you missed a question that I got right, or if you got all the questions right. You can brag about it in the comments, and I'll give you a shout out in my next video. I hope this is helpful for you guys. I hope you enjoyed the video. If you did, please leave a like, subscribe. It definitely means a lot to me whenever anyone subscribes to the channel. I have a lot of fun making these videos, and it helps me to know that people are actually interested to watch them. So I'm happy to keep on making them for you guys. And I hope you'll join me in the next video as well. Bye!